Hey, Giselle, this is Jeff Barrows. Thanks for sending me the details here. What I thought I would do, I think it'd be probably a little easier to just do a little video for you here and show you how this is done. There's a lot of a lot of crazy notation and calculations here. So I thought this would be easiest. So right here is the data that you sent me. And anytime you get into this business of wanting to find percentiles or quartiles or deciles or whatever it is that you are trying to find here, the first thing you want to do is you want to start by ordering your data from low to high. So as I look down through here, this is what you sent me. It looks like we're good in that regard. So we can get going here. In the reading, equation 4.1 shows you this equation. This LP equals n plus 1 times P over 100. This is basically saying for a certain percentile, this calculation is going to tell you the location of the value that satisfies whatever percentile or quartile it is you're looking for. And when I say position, I'm saying your position in this string of values. For example, you have 30 values here, and if I was looking for a value and it happened to be this LP calculation came out to be 20th, what it would say is the 20th value in the string is the answer to the question that I'm looking for. So what I thought I would do here, because I want to show you this calculation. What I thought I would do is I would at least show you one of these calculations and then show you there's a little bit of a rounding issue down here in the case of a non-integer value. So let's just go through, maybe we'll go through a couple of these and make sure this makes sense. So the first question you sent me is what are the first and third quartiles? So the first thing that we should know is that the first quartile is the 25th percentile, and the third quartile would be considered the 75th percentile. So in this calculation, again, remember LP is the location of a certain percentile, n being the number of values in your string. You happen to have 30 times P over 100. So if you look at this substitution that I've done here, the location of the 25th percentile would be 30 plus 31, again 30 because you have 30 values, times the percentile that you're looking for the 25th percentile divided by 100. So if I go over here and do the math on this real quick, 30 plus 1 is going to be 31 times 25 over 100 is 0.25, and that gives me 7.75. So 7.75. And again, what that's saying is that is the position of the value that is at the 25th percentile. Now, obviously, there's not a value here at the 7.75 position in your string because we're counting these as whole numbers. But let's look at and find here. So let's go value 1, 2, 3, 4, 5, 6, 7. So let's mark, let me see if I can move this little string out of here. Oops, I didn't mean to do that. Let's see. Well, let's just remember, let's see, is there any reason I can't do something with that? I'm just trying to move this little one. It's moving the whole thing. So let's just remember, well, actually, here's what I can do. Here's the 7th value, and here's the 8th value. This should work for us. So what this is saying here in this discussion is right below equation 4.1 in the reading. It's saying that if you compute a position and you come up with a fractional value here in addition to the integer, what it's saying is you're going to, in this case, it tells you that you're going to go 25% of the distance in between, in this case, again, it would be the two values here that we're looking at. So the 25th percentile for us is going to be 75% of the way in between 7 and 8. And so what I need to do here, obviously, if we just take the difference between 33 and 30, we know that that is 3. And so what I'm going to add to 30 is 75% of the distance from 30 to 33. So if I take 0.75 times 3, what that's saying is I'm going to add to the 7th value, I'm going to add 2.25. So the 25th percentile 25th percentile is going to be 30 plus 2.25, and that is equal to 32.25, right? So that is, that would give us the 25th percentile. Let's see, so I think you can go ahead and do this. The 75th percentile, the only thing that's going to change here, it'll be L. Let me just start you with a notation here. So L75, the location of 75th percentile, it's still going to be 30 plus 1 times 75 over 100, and then you can go ahead and you can compute that. Let's see. Let's do one in part B. I think that would be helpful because deciles a little bit different here, but these are counting by tens. So the second decile is the 20th percentile, and the eighth decile would be the 80th percentile. So let me do the 20th percentile. So the location, let me make sure I don't lose that, but I'll just get out of the way. I don't think we need that. The location of the 20th percentile is going to be, again, same as before, 30 values plus 1 times 20 over 100. So if I go do the math over here, the location of the 20th percentile is going to be 31 times 0.20, and that's going to be at the 6.2 mark. 6.2. So I'm going to go back and do the same thing I did before. Let's see, let's count 1, 2, 3, 4, 5. So here's my sixth value, and here is my seventh value. So again, it's going to be the sixth value and then 20% of the distance between 28 and 30. So 30 minus 28 is 2. So if I take equals 2 times 0.20, which again is this piece right here, this fractional value, what I'm going to add to that is 0.4. So the 20th percentile is going to be 28.4. And again, that being the sixth value and then 20% of the way between the sixth and seventh value. Because the difference between the sixth and seventh value is 2, and I take 20% of that, that's 0.4. So that's how I come up with 28.4. So let me know if this helps. If not, shoot me back a note, and maybe we just need to hop on the phone and go over that. But I hope this is helpful. Thanks, and have a good day.